Welcome back. This is section 8.2, Impulse Changes Momentum. In your textbook, this is section 7.2. Okay, we have a new term that you've never heard, I bet, and that's called impulse. An impulse, defined by definition, is going to be the time multiplied by the force. So if you exert a force over a certain amount of time, that's called an impulse. The amount of impulse will affect the change in momentum. If you remember that the momentum, which is rho, is equal to mass times velocity. So if momentum changes, what had to change? Well, either the mass had to change or the velocity had to change. So if I'm throwing a ball or crashing a car or shooting a bullet, most of the time the mass doesn't change. The mass stays the same. So what we're really looking at often is a change in its velocity. The velocity is going to change. It's going to go from slow to fast or from fast to slow. And as it changes, the momentum is changing. Well, what caused it to go from fast to slow or from slow to fast? Okay, so how do I have a baseball that's going 0 meters per second all of a sudden going 5 meters per second? Well, I had to put a force on it. If I put a force on that baseball, I can change its speed from 0 to 5 or whatever, however hard I can throw it. So as I exert a force, I can change its speed. If you remember, the speed is going to be how much distance is it changing per time, and that requires a force. The acceleration of making something change its speed, which is acceleration, is based upon the force you put on it and how much mass there was. So if the mass doesn't change, then the higher force that I put on that mass, the greater the speed that I can make it go, because it's accelerated, say, from 0 to 5, and now it's going 5. Now, any of you that are in sports, you are told, whether you are hitting a baseball or shooting a basketball or hitting a golf ball, all of these impacts with the ball is going to distort the ball. As you're throwing the volleyball or as you are hitting the volleyball, you are distorting that ball. You are making it deform into where it's not round anymore. Then when it bounces off of your hand, it's going to basically spring back, and as it's doing it, you've accelerated that ball. The longer you can keep your hand in contact with the ball, or the bat in contact with the ball, or your foot in contact with the ball, the longer you can keep that going, the greater the change in velocity. You can make it go farther by keeping your foot in contact with a soccer ball longer than just a quick kick. A quick kick might make it go, but a long kick can make it go far. That's why in volleyball there's actually a rule against like holding onto the ball, because they realize that you can get it going faster the longer that you hold that ball. So there's rules against that for that reason. So we have to realize that if I can make the force longer, I can make more change in momentum. And that's what impulse is. Force times a change in time. So how making it longer will increase the change in momentum. And if you remember, momentum is rho, which means that force times time equals mass times velocity. Well, if my mass doesn't change, then what's happening? If I can make this go higher, I'm making this go higher. So a force times a mass is going to give you a higher velocity at the end. So that is called impulse. Impulse is force times time, and force times time is going to be a change in the momentum. So specifically in the velocity. The velocity goes higher, and the change in momentum is higher as a result. So if you want to change momentum the greatest, you need to keep the force in contact with the object that's being moved as long as you can. So if you, for instance, want to throw a ball and you want to throw it as fast as you can, you've got to keep your ball in contact with your hand as long as possible. That means that you're actually rolling the ball off of your fingers. You're not just palming a ball and forcing it forward. You're trying to keep your hand moving that ball so that that force is times a longer amount of time. Likewise, if you want to slow down a ball, so you want to catch a ball and you want it to not do as much damage. Let's say you're playing a ball without a baseball glove and you're catching a fastball. The way you slow it, if you slow it down a long time, like you keep your hand in contact with the ball as it's slowing down, the longer you can do that, the less impact that the force is going to have on you, because that's an impulse too. You're changing its momentum by applying a force as long as possible. So here's to review. The force of impact on a golf ball varies through the duration of the impact. So at the beginning, before you actually touch the ball with the golf club, you don't have any force at all because it's not touching. Then at the very beginning, as that ball collapses and it's not round anymore, you're exerting a tremendous force on that ball, and so it's going to accelerate very, very fast. Then the ball comes back to shape, and as it's coming back to shape, less and less and less is touching the club, and it's diminishing in acceleration. And then when it leaves the club, it has no acceleration again. It's just moving at whatever speed it left the club at. So we're going to use the average force. When I say Ft is impulse, the F is the average force, not the initial force or not the end force, but the average force over which you contact the ball times the time, and that's the change in momentum. Okay, here's a review screen. If you needed to crash your car, would you rather crash your car into a concrete wall or into a haystack? I think anybody would crash it into a haystack. What's happening, though, is that the haystack, we think of it as softer, but the haystack is still stopping the car. And if it's stopping the car, then it must have exerted the same force. So a haystack can stop a car, and a wall can stop a car. What's the difference? The haystack will stop a car very, very slowly, okay? Or say a rubber band. Some of you very strange people will actually get into a big rubber band at an amusement park and zip back and forth and back and forth. The longer you can stretch a bungee cord, the slower you stop. You're moving forward, and then you're slowing down, and then you stop, and then you go backwards. The longer you can keep that rubber band, the slower that you can do it, the more of a change in momentum that you can have. So if you hit the haystack, it slows your car down to zero, but it does it very, very slowly, and so the impact of the force is less. If you crash your car into a wall, it still stops your car, but it stops your car in a split second, and the impact of that force is now extreme. Okay, so here's a picture. We've got a momentum here. We've got mass times a high velocity, so it's got a momentum. At the end, that momentum is equal to impulse. So the same amount of momentum that it had at the beginning, these two things are equal to each other. So the force times a great long time, so the higher amount of time that you're stopping that car, the smaller the force is. Well, the smaller the force is, the less damage it does on your car, the less damage it does on your brains. So you want, if you're slowing something down, you want to do it over a long period of time. If you have a high velocity here, then mv is going to be rho, so you have a huge momentum. Well, that momentum is equal to impulse. That means that if I have a very short time, say the amount of time it takes to crash into a wall is a very short time, then I have an enormous force. That enormous force is going to crash my car. It's probably going to kill me. So the longer you can stop an object, the less force you're going to have an impact. The longer you can throw an object, the more speed you can get from it, even if you are weak and don't have a lot of force to throw a ball with. Throw it over a longer period, and you'll get a greater change in momentum. So if you're going to jump down off of something high, you don't just jump down with straight legs. You will bend your legs as you jump down, because as you bend your legs, you are increasing the time over which you're changing the speed. You're going fast as you fall off the table or off of the roof. And then as you bend your legs, you're extending that time. As you extend the time, you're reducing the force. Because the momentum is going to be the same. The momentum is equal to the impulse. The impulse is force times time. So the higher time, the less impulse. Force and time are inversely proportional. As one goes up, the other is going to go down, and you'll have less damage on your legs. If the wrestler, or let's say someone that works on the movies as a stuntman and is jumping out of a car, if you want to fall as long in contact as you can with the ground, and by doing that, you're going to have less damage on you. If you're about to get punched in the face, what are you going to do? You move your head back. Why? Because as the fist hits you in the jaw, you are pulling back, you have more time in contact with that person's fist, and it's doing less damage to your face. Stupid people would push your head into someone's fist, because what's happening is that then you're going to change your speed of that fist much, much faster. So don't do that. Always go back. If someone's going to hit you, you run away. So here's the poor guy that thought he should go into someone's punch. Didn't do well for him. If a glass falls out of your hand onto a hard floor, it's more likely to break than if it were to fall onto a carpet. The carpet gives some, and as it gives some, it extends the time that it's changing its speed, and that extension in time reduces the force. If you want to fall from a trapeze, a lot of times they'll have a net. Why is the net going to keep you from dying? Because if you fall into a net, it extends the amount of time that you're falling, and by extending the time, you're decreasing the force. So did you learn this? What factors affect how much of an object's momentum changes? The change in momentum, which is indicated by a delta, a change in momentum, which is equal to a change in mass times velocity, is equal to impulse. And impulse is force times time. So if you want more force, make it a shorter time. If you want less force, make it a longer time.